Okay, so yesterday we have solved these two problems in Lagrange multipliers. So this question is asked in 2005, this question is asked in 1975. Right, so yesterday I didn't write the year of asking, so this question is asked in 2005 and this question is asked in 1975. So now we'll move on to the third problem now. So third problem is third problem is 3z minus 4y into p plus 4x minus 2z into into q is equal to 2y minus 3x. 2y minus 3x. So we are going to solve this using Lagrange multiplier. So we need to find two multipliers. So first we will write the subsidiary equation. The subsidiary equation is dx by 3z minus 4y dy by 4x minus 2z and dz divided by 2y minus 3x. So we need to find two multipliers. These two questions are already solved yesterday. I'm not going on done. And these two questions are already solved yesterday, right? So here first we need to find two multipliers. So first we will recall what is meant by Lagrange multipliers, right? So we need to find a triplet L comma n. This can be a constant, this can be a function, such that if L into capital P, this is capital P, M into capital Q plus N into R is equal to 0, then integration of L dx plus M dy plus N dz is one of the solution. This is what Lagrange's multipliers. So we need to find two multipliers. So you can see if I take the multiplier taking multiplier x comma y comma z. So we take the multiplier x comma y comma z. So you can see this will become 0. Why? Because x into 3z minus 4y plus y into 4x minus 2z plus z into 2y minus 3x. So this will be 3xz minus 4xy plus 4xy minus 2yz plus 2yz minus 3xz. So this 2 will get cancelled, this 2 will get cancelled, this 2 will get cancelled. So therefore if I take this multiplier, this condition satisfies. If this condition satisfies, then integral of L dx plus M dy plus N dz is one of solution. Therefore integral of x dx plus y dy plus z dz is one solution. So therefore if I integrate this, I have x square by 2 plus y square by 2 plus z square by 2 is equal to C1, or C1 is equal to x square plus y square plus z square. This is one of the solution. Now we need to find another set of multipliers. Now if I take 1 1 1, this will not be multiplier because 3z, here there is no minus 3z anywhere. So 1 1 1 will not be a multiplier. If I take 1 by x, 1 by y, 1 by z, again this will not be a multiplier because here we will have 3z by x. There won't be minus 3z by z, minus 3z by x anywhere. So therefore 1 by x, 1 by y, 1 by z will also be not be a multiplier. Now we carefully see this. Here we have 6z, here we have 2z, right? So and again you can see x, here we have 2x, here we have minus 3x, right? And here we have 4y, here we have 2y, here we have 2y. Now if I multiply 2 here, if I multiply 2 here, okay, if I multiply 2 here, we will have 6z. If I multiply 3 here, we will have minus 6z. So if I multiply 2, if I multiply 3, this 6z and minus 6z will get cancelled. If I multiply 2 again here we will have minus 8y, minus 8y. If I multiply Yes, so first I will write it and then I will explain you. I am going to take the multiplier 2 comma 3 comma 4. So this is one of the solution, x square plus y square plus z square. Now I am going to take another multiplier 2 3 4. You just have to find a triplet such that LP plus MQ plus NR is equal to 0. So for second I am going to take multiplier. So take multipliers 2 comma 3 comma 4, that is 2 into 3z minus 4y plus 3 into 4x minus 2z plus 4 into 2y minus 3x. So if you do this, you will have 6z minus 6y, 6z minus 8y plus 12x minus 6z plus 8y minus 12x. Again this all will get cancelled, this is equal to 0. So therefore integration of 2 dx plus 3 dy plus 4 dz is one of the solution. Therefore 2x plus 3y plus 4z equal to C2 is another solution. Therefore f of C1 comma C2 is a solution. So our C1 is x square plus y square plus z square, and our C2 is 2x plus 3y plus 4z. So the first multiplier for this problem is x comma y comma z. The second multiplier is 2 comma 3 comma 4. So we'll move on to fourth problem. The fourth problem is x into y square minus z square into p plus y into z square minus x square into q is equal to z into x square minus y square. So first we will write the subsidiary equation. So it is dx divided by x into y square minus z square dy divided by y into z square minus x square is equal to dz divided by z into x square minus y square. Now if I take the multiplier again x by z, so first I am going to take the multiplier. So take multiplier x comma y comma z. So if I take this, you will have x into x of y square minus z square plus LP plus MQ plus NR has to be equal to 0. X into this term plus y into this term plus z into this term. So if you do this, you will have x square y square minus xz square, right? X square y square xz square plus y square z square minus yx square plus z square x square minus zy square. So x square y square y square x square. So x square y square minus x square y square will get cancelled, and sorry, this x square z square. So x square z square, this will get cancelled again, this will also get cancelled. Therefore this is one of the multiplier because LP plus MQ plus NR is equal to 0. So therefore our solution is integral x dx plus y dy plus z dz is equal to C1. So therefore our C1 will be equal to, so our C1 will be equal to x square plus y square plus z square. This is one of the solution. Now I am going to take the multiplier. So take multiplier 1 by x, 1 by y, 1 by z. So if I take this multiplier, we should have 1, if I get 1 by x into this plus 1 by y into this plus 1 by z into this is equal to 0, then this is one of the multiplier. Now if I multiply 1 by x here, this x and this will get cancelled. So we have only y square minus z square plus I multiply 1 by y here, this y and this y will get cancelled. So we have only z square minus x square, and if I multiply 1 by z here, z will get cancelled. So we have x square minus y square. So again all will be cancelled, and this is equal to 0. So therefore this is one of the multiplier. So integration of 1 by x plus 1 by y plus 1 by z dz is one of the solution. So therefore this is nothing but log x plus log y plus log z, and I am taking constant to be equal to log c2. So therefore this I can write this as log xyz is equal to log c2. So c2 is equal to xyz. Therefore solution is f of c1 comma c2 is equal to 0. Our c1 is x square plus y square plus z square, and our c2 is xyz is equal to 0. This is one of the solution. So we move on to fifth problem. So y square plus z square into p minus xy into q plus xz equal to 0. So first we will write the subsidiary equation. So it is dx divided by y square plus z square is equal to dy divided by minus xy dz divided by minus xz. I have to take this term to that side. So again if I use the Lagrange's multipliers x comma y comma z, so taking multipliers x comma y comma z, so x into y square plus z square plus y into minus xy plus z into minus xz. So this will be equal to x square y square x square z square minus x y square x z square minus x y square minus x z square. So again this two will get all will be equal to 0. So therefore integration of x dx plus y dy plus z dz. So therefore c1 is equal to x square plus y square plus z square is one of the solution. Now to find another solution, I am going to use method of grouping. You can find any two solutions anyway. You can also find another multiplier, but I am going to use method of grouping for this term and this term. So let dy divided, you have to find two solutions, that's it. So dz divided by minus xz. So xx will get cancelled. So minus minus will get cancelled. So we have dy by y is equal to dz by z. So if I integrate this, we will have log y is equal to log z plus log c2. So log y minus log z is equal to log c2. So that means c2 is equal to y by z. So therefore our solution is f of x square plus y square plus z square and y by z is equal to 0. We can see because for these two variables we have one variable reduced. So if we do using a method of grouping also, it will be very easy for you to follow. So solution is f of x square plus y square plus z square comma y by z. It is not that this is one of the unique solution. You can also find some other multipliers. You can also use multiplier and grouping in one single sum also. It is not that if you are grouping, you should not. You can use one grouping. You can use one multiplier also. You have to find two solutions. That's it. You can do that in any way. So sixth problem, x y square plus into p plus y into x square plus z into q is equal to z into x square minus y square. So first we will write the subsidiary equation. So it is dx divided by x into y square plus z square is equal to dy divided by y into x square plus z is equal to dz divided by z into x square minus y square. Now if I take the multiplier 1 by x, 1 by y, 1 by z, this x, this y, this z will get cancelled. So we have y square here minus y square. Here we have z. Here we have plus z. Here we have plus z, right? So here z will not cancel. So again here we have x square. Again here we have x square. So what I am going to do is I am going to take the multiplier. So take the multiplier 1 by x minus 1 by y, 1 by z. So instead of plus 1 by y, I am going to take minus 1 by y. So that minus x square plus x square will get cancelled. Minus xz plus xz will get cancelled. So we take this multiplier 1 by x into y square plus z plus 1 by y into x square plus z plus 1 by z x square z into x square minus y square. This is equal to 0 because all get cancelled. So therefore integration of 1 by x minus 1 by y plus 1 by z will be a solution. So this is equal to log x minus log y plus log z is equal to log c1. So from this I can write log x by y plus log z equal to log c1 because all are not plus. If all are plus, we can write log x by z. So from this I am using log a by b. So from this I can write this as log a plus log b is equal to log a by b is equal to log c1. So therefore c1 is equal to xz by y. Xz by y. So now we have to find another multiplier. So for finding another multiplier, so here you can see here we already have x square. Here we already have x square, but here we don't have x square, right? So in order to get x square, we need to multiply x here. So multiply x here, we will have x y square, and here again you will have x square y. Sorry, if you multiply x here, and if you multiply y here, we will have x square y square, x square y square. So one of them has to be opposite sign. And if I multiply x here, this term will become x square z, and again here we have x square z, right? So I am going to use the multiplier x comma minus y comma. So if I take x square y square minus y minus 1. Yes, x minus y minus 1. So if I take this multiplier, you can see x into x y square z plus minus y into x square plus z minus of zx square minus zy square. So you can see this is x square y square, and this x square y square will get cancelled. So here we have plus xz, and here we have plus x square z, and here we have minus x square z. So all the term will be equal to 0. So therefore integration of x dx minus y dy minus 1 into dz is one of the solution. So therefore C2 is equal to x square by 2 minus y square by 2 minus z. Or else you can also write this, you can equate to be equal to x square minus y square minus 2z divided by 2. So this 2 I can bring inside. So I can name C2 to be equal to x square minus y square minus 2z. So therefore solution is f of xz divided by y, comma x square minus y square minus 2z is equal to 0. The only thing is you have to make them 0. We can use any operation. So here I am using x comma minus y comma 1. So 7th problem, this question has said 1973. X square minus y square minus z square into p plus 2xy cube is equal to 2zx. So first we will write the subsidiary equation. So it is dx divided by x square minus y square minus z square dy divided by 2xy dz divided by 2zx. So I can equate this term and this term, so I can easily get one solution by method of grouping. So let dy divided by 2xy is equal to dz divided by 2zx. So x's will get cancelled. So 2 will get cancelled. So we have dy by y is equal to dz by z. So therefore, to integrate this, we will have log y is equal to log z plus log c1. So c1 will be y by z. Now we need to find another multiplier. So what I can, if I multiply x, y, if I use a multiplier x, y, z, you will have this to be equal to x cube. But here we don't have x cube anywhere. So x, y, z is not a multiplier. If I use 1, 1, 1, again here we have x square, but we don't have minus x square. So again 1, 1, 1 will not be a multiplier. If I use 1 by x, 1 by y, 1 by z, again this will not be a multiplier, because here we have x square minus y square minus z square. So we can see any number, if you take any fraction, it will not be a multiplier. So we have to approach this sum in a different way. So further what I am going to do is, it's a very important problem. You cannot find any 3 multipliers as easily for this sum, right? So what I want to do is, so first I am going to use multiplier x comma y comma z. So if we do that, we will have x dx plus y dy plus z dz divided by x into x square minus y square minus z square plus y into 2xy plus z into 2zx. If this is equal to 0, then this will be a solution. Integration of numerator will be a solution. But what worst case is, here the denominator is not equal to 0. So but anyway, we are going to use this. We are going to have this is same as this, right? We are going to equate this term and this term now, because what we are doing is we are just multiplying dividing by x. So it won't take this equation won't make any difference. So I am going to write this is equal to this term x dy plus y dx plus z dz divided by this entire term, and then I am going to equate this term and this term. I am going to group this term and this term, right? So first I am using this multiplier. If this is equal to 0, then this is a solution, that is integration of numerator is solution. But since this is not equal to 0, I am going to equate this to any one of them here. So I am going to use equate to dz by 2zx. So before that, what we will do is we will simplify this. If we simplify this, we will have x dx plus y dy plus z dz. There is no any standard method to solve here, right? If you can't find any multiplier, you have to use this multiplier and then you have to group with one of the term, right? You can do anything, you have to find solution, that's it. Now if I multiply x square inside, you will have x cube minus okay, we will write x cube minus xy square minus xz square plus 2x square y plus 2z square x. Now I am going to equate this with dz by 2zx because this is equal to all three. So I am going to group this term and this term. So minus xz square is x cube now if I add this, we will have x dx plus y dy plus z dz divided by now 2x square y minus this xy square. This xy square. Now I can add minus xy square and plus 2xy square. So we will have x cube here. So if I add this term and this term, we will have plus xy square. And if I add this term and this term, again we will have plus xz square is equal to dz divided by 2zx. Now if I take x common here, I can cancel this x and I can take x common here. So if I take x common here, this equation turns out to be x dx plus y dy plus z dz divided by x square plus y square plus z square is equal to dz divided by 2z. So we have taken x common here. So we have x square, y square, z square and this x will get cancelled. So we have so I can take 2 to, if I take 2 here, what we will have is I can write this as, if I take 2 here, I can take 2 here, so I will just erase it 2 here and then I can take 2 here, right, and just cross multiply. So I can write this equation to be d of x square plus y square plus z square. Why? Because if I integrate this, what I will have? X square by 2, y square by 2, z square by 2, right? So I can write this as, okay, we will do this as it is. So if I can write this as d of x square plus y square plus z square, because if I differentiate x square, we will have 2x dx, here 2y dy, here 2z dz. So I can write this entire numerator to be d of x square plus y square plus z square divided by x square plus y square plus z square is equal to dz divided by z, right? Now if I integrate this, I will get the answer, that's it. So if I integrate this on both sides, so if I integrate this is nothing but log of x square plus y square plus z square and this is log z plus log c1. We know that integral dx by x is equal to log x. So instead of x, we have x square y square z square, x square y square z square. So therefore the integration will be log of x square y square z square and that is log c1, log z plus c1. So if we bring this to this side and if we equate that with c1, so we have log of x square plus y square plus z square minus log z is equal to log c1. So if I use log a minus log b formula, we have c2 to be equal to, you write c2, so c2 to be equal to x square plus y square plus z square divided by z. This is our second solution, right? So I have used first I used method of grouping to this term and this term. So I got the first solution to be y by z. Now there is no multiplier such that this into this, this into this, this into this will give you 0. Now I am going to use the multiplier x y z. If I use this multiplier, this term, this term, this term, this term all are equal. Now I am going to equate this term and this term, right? If I equate this term and this term, you can also equate this term and this term also. Here you will have dz, integral dz by dy by y, that's it. So we have log y, instead of log z we are going to have log y. So you can also you can equate with this term and this term. So I am going to equate this entire term to be equal to dz by 2zx. Now if I multiply here, if I am just making a multiplication and then subtraction, so we have x square y square z square. So I can replace this entire term to be equal to d of x square plus y square plus z square, and here we already have x square plus y square plus z square. So d of something divided by something will give you log of something. So this is log z plus log c2. Therefore c2 is equal to x square y square z square by z. We move on to 8th problem. If you don't get multiplier, you have to make some adjustment like this to get the answer. So now you can do this problem, 9th problem, you can do this now. Z square minus 2yz minus y square into p is equal plus xy plus zx into q is equal to xy minus zx. So you can do this. You can just take 2 or 3 minutes, and also you can take 4 minutes also. You can do this. You need to practice more problems, right? So after this, I will just tell the page number of the book. You need to practice all the problems, because I can't do all the problems in the book. Why can't we equate the first two term using grouping? You can try this. If you get the answer, that is also an answer. So here you can first you can write the auxiliary equation to be dx divided by z square minus 2yz minus y square dy divided by xy plus zx dz divided by xy minus zx. Now you take the multiplier x comma y comma z. So take multiplier x comma y comma z. This will be one of the solution. You can see xz square here minus xz square, this will get cancelled. So here we have minus 2xyz, here we have plus xyz, here we have plus xyz. So again this will get cancelled. So x comma y comma z will be one of the multiplier. So therefore the solution will be one of x c1 is equal to x square plus y square plus z square. You can also find some other multiplier, or else you can also equate, you can group this term and this term, because if I take x common here and if I take x common here, one x will get cancelled. So one variable is reduced. So if one variable is reduced, we can use grouping. So dy divided by x into y plus z is equal to dz divided by x y minus z. So this will get cancelled. So if I cross multiply this, we will have y dy minus z dz is equal to y dz plus z dz. So I can write this as y dy minus z dz minus y dz minus z dz equal to 0. Y dy minus z dy. Now I can write this entire term to be equal to y dy minus z dy plus y dz minus z dz. I can write this term to be equal to y dy minus d of xz yz, d of yz, y into dz plus z into dy minus z dz. So if I integrate this, so integrate, we will have y square by 2 minus yz minus z square by 2 equal to 0, or else this will be equal to C2. So C2 will be equal to y square minus 2yz minus z square. This is also one of the solution. If you found some other multiplier, that is also one of the solution. So first solution is x square y square z square, and then y square minus 2yz minus z square. So you try one more problem. And then you have to write f of c1 comma c2 is equal to 0. Y into y minus xz into p plus yz minus x into q is equal to x plus y, x minus y. Now you find two multipliers. So we found two multipliers. You need to find two multipliers, that's it. So one is xyz, what is another? One is xyz, second one is, okay, the first multiplier is x comma y comma z. Second multiplier is y comma x comma 1. Y comma x comma 1 is the second multiplier. You can do this in any way. So I have chosen y comma x comma 1, right? So therefore our C1 will be x square y square z square, and our C2 will be y square plus x square, sorry, integral y dy, right? So if I choose this multiplier y comma x comma 1, we will have, so C1 will be x square plus y square plus z square. Now if I choose the multiplier y comma x comma 1, our solution will be integral y dx integral x dy. Okay. y dx plus x dy plus dz equal to 0. Integration of this will be as I can write this first two terms to be d of xy plus dz is equal to 0. Now if I integrate this, we will have only xy. Here we have only z equal to c2. So our c2 will be xy plus z. So first multiplier is x comma y comma z, second multiplier is y comma x comma 1. Answer need not be unique. Yes, yx1 is second multiplier, yes. So 11th problem, y minus z into p minus 2x plus y into q is equal to 2x plus z. Can do this. So here the first multiplier is 1 comma 1 comma 1, right? Straight away y plus y minus z plus z minus 2x plus 2x. So this is one of the multiplier. So therefore C1 will be x plus y plus z. So what will be my subsidiary equation? Yes, dx divided by y minus z, dy divided by minus of 2x plus y, dz divided by 2x plus z, 2x plus z. Now I am going to take these two equations, right? I am going to take these two equations, I am going to group. So dx divided by y minus z, dz divided by 2x plus z. Now here the two variables are x and z. Here the two variables are y and z. So you need to transform this to again a variable of xz. So for that I can write y to be equal to c1 minus x minus z. So I can replace here y to be equal to c1 minus x minus z here as it is, right? So I am going to replace y to be equal to c1 minus x minus z, and here we are going to have dz divided by 2x plus z. So here we have dx divided by c1 minus x minus 2z. Again I am telling there is no any standard procedure, right? You just have to group or just have to use multiplier, or else you have to add dx plus dy. You can do anything. So dz divided by 2x plus z. So now we can cross multiply and then we can integrate, we will get the required answer. So if I cross multiply this, we will have 2x plus z dx is equal to c1 minus x minus 2z dz. Why we can't cross multiply? You can do any method. It is not that this is the procedure. You can do any method, right? If you get the answer, that is also one of the solution. That's it. If you take the multiplier, that is equivalent to 1 comma 1. If you take the multiplier x comma x comma x, that is equivalent to 1 comma 1 comma 1. So 2x dx so if I integrate this, so for before that I will group this also, 2x dx now if I can write this term to be equal to d of xz, d of xz, x dz plus y dy. So if I integrate this, here we are going to have x square by 2, here we will have only xz, here we have z square by 2, right, z square by 2. dz. Now if I integrate this, you are going to have here x square plus xz plus z square is equal to c1 z plus c2, right, x square by 2 we will have, so 2 will get cancelled, x square plus xz plus z square by 2 will get cancelled, so we have c1 z. Now I can replace c1 to be equal to again x plus y plus z. So we have x square plus xz plus z square minus c1 z equal to c2. Now you replace c1 to be equal to x plus y plus z. Now then you multiply with z and then you cancel some term, you will get c2, right. So you replace c1 to be equal to x plus y plus z, you multiply z inside, so we have minus xz, this minus xz and this plus xz will get cancelled, and we are going to have minus z square and this plus z square will get cancelled. So we have left with x square minus yz equal to c2. Therefore solution is f of x plus y plus z comma x square minus yz. 2004, x into y square plus z into p minus y into x square plus z into q is equal to z into x square minus y square. Now you can do this problem now. You just find two multiplier for this. One comma one. X y square minus xy square plus xz. No. 1 comma 1 is not a solution. Here we will have xz. Here we have x square z. xz is also not a solution. If you take x, here you have x square y square. Here you are going to have minus x square y square. If you take x here, you are going to have x square z. Here you are going to have zx square. This is also not a solution. X comma y comma 1 is also not a solution. If you take x, y here, come very closer, x comma y comma 1. X comma y comma minus 1, then only you will get 0. X comma y, yes, x comma y comma minus 1 is one multiplier. Now you define another multiplier. So x dx plus y dy minus 1 dz. So therefore 1c1 is equal to x square plus y square minus 2z is c1. The first multiplier is x comma y comma minus 1. X comma y comma minus 1. So c1 will be x square plus y square minus 2z. Now you find another multiplier. Yes, 1 by x, 1 by y, 1 by z. So for 1 by x, 1 by y, 1 by z, we will get x, y, z as a solution, right? Because already did. So another multiplier is 1 by x, 1 by y, 1 by z, and solution C2 is x, y, z. So now we will move on to 13th problem. The 13th problem is 1990. So y square plus z square into p minus xy into q plus xz equal to 0. Now you can find one solution easily. You can group this term and this term. You will get one solution because you can see this x will cancel. So we have integral dy by y, integral dz by z. So we have log y minus log z. Y by z will be one of the solution. Now you find another multiplier. you can go with 2 multipliers, or 1 multiplier, 1 grouping, or 2 grouping, or 2 multiplier. You can do anything, or else you can also make some adjustment, like you can add dx plus dy plus dz, or you can also add dx plus dy. You can also add dx minus dy. You can do anything. So you can group first. You will get subsidiary equation. So dx divided by y square plus z square, dy divided by minus xy, dz divided by minus xz. So if you group this term and this term, so this minus x will get cancelled. So we integrate this, we will have log y is equal to log z plus log c1. So therefore log c1 is equal to log y minus log z. That means c1 is equal to y by z. Now you find one multiplier. One by x, 1 by z. One by x, 1 by z. If you choose second multiplier as 1 by x, how do you integrate with respect to y? You cannot do that, right? Yes, xyz is one multiplier. So xyz is one multiplier. So you can take multiplier x comma y comma z. So we will have c2 to be equal to x square plus y square plus z square. So y by z is one solution, and x square plus y square plus z square is another solution. This is 2001. My into x plus y minus n z square into p minus lx into x plus y minus n z square into q is equal to lx minus my into z, right? So first take multiplier. I already solved one sort of problem like this. I want to take multiplier lx my nz. So take this multiplier lx my nz. So you will get this entire term to be equal to 0. So therefore integration of this will be one solution. If you integrate this, you will have lx square by 2 my square by 2 nz square by 2 equal to c1, or c1 to be equal to lx square plus my square plus nz square. Now for find the second multiplier, what I am going to do is, so first we will write subsidiary equation. So it is dx divided by my into x plus y minus nz square, dy divided by minus lx into x plus y minus nz square, dz divided by lx minus my into z. Now what I am going to do is, if I add this term and this term, so here you can see this is a function of lx, x, y, z. Now what I am going to do is, first I am going to add dx plus dy. So if I add dx plus dy, so here we will have my into x plus y minus nz square minus lx into x plus y plus nz square, because you have minus here, so minus plus. So if I add this, this 2 will get cancelled. If I take x plus y outside, so we have dx plus dy divided by If I take x plus y common, we have my minus lx of x plus y. Now I am going to equate this with this term. If I equate this with this term, lx minus my will get cancelled. So if I interchange this term, so I can write this term to be equal to dx plus dy divided by, okay, let me take this term as it is. Now I am going to equate this and this, right? We have did one problem. We did x dx y dy plus z dz. Now I am just doing 1 dx plus 1 dy. If I equate this term and this term, so we have dx plus dy divided by my minus lx of x plus y is equal to dz divided by, you can take minus outside, so we have minus m into lx into z. So this term and this term will get cancelled. So we have dx plus dy divided by x plus y is equal to minus dz by z. Now I can write this term to be equal to d of x plus y divided by x plus y is equal to minus dz by z. So I integrate this is log x plus y, right? So on the previous sum we have d of x square y square z square divided by x square y square z square. So if I integrate this term, we will have log x plus y minus log z plus log c1 or c2. So if I bring this term to this side, so I will have log x plus y plus log z equal to log c2. That means c2 is equal to z into x plus y. So c1 is lx square plus my square plus nz square, and c2 is, there is no any standard procedure, that's what I am saying. So you can mix up anything, you have to get two solutions, right? So but straight away you can see these two equations. If I add this term will get cancelled. If I take x plus y common, lx minus my will be there, and if I equate with this term and this term, this two will get cancelled, we get the answer very easily. The only thing is you need practice, right? So we are going to solve 16 problems now, right? 16 problems now. I am going to solve 2 problems, and then I have given the book in Telegram, right? So I will tell you the page number. You have to solve all the problems, right? There will be, in every problem there will be different multipliers, or they will be following some different procedures like adding dx plus dy and then equating with some other term, etc., right? So I'll do 2 more problems, and then you have to do all the remaining problems in that book, right? So we move on to the next problem. Now 1992, 15th problem. Two x square plus y square plus z square minus 2yz minus zx minus xy into p plus x square plus 2y square plus z square minus yz minus zx minus xy into q is equal to x square plus y square plus z square, so 2z square minus yz minus zx minus 2xy. Now here what I am going to do is, I have already sent the PDF in the Telegram group, right? You please check that in files. In files there will be a PDF. I already sent PDF. Page number I will let you know later. So you should not panic by seeing this problem, right? Because question result is very big. So here what you are going to do is, first you write subsidiary equation. So subsidiary equation is dx divided by 2x square plus y square plus z square minus 2yz. Actually you don't need to worry, because every problem is there in rising area book. Whatever they ask, this problem is same in rising area book, right? So you don't need to worry. If you solve all problems in rising area book, 98% you will get only the same problem which you are solving, because you can see every problem I have solved all are the previous year's questions, all only from rising area, right? So you don't need to worry, because we already solved 16 problems now. So there will be around another 6 or 10 problems will be there. You can practice that. So there will be, if you practice 30 problems, so if you get, I'm surely you will get only one problem from this 30 problems only, because whatever they are asking, they are only asking from rising area book as it is. They are not even changing the question, they are not even changing the plus or minus sign, as it is, right? Sorry, low battery. Okay, I quickly do this. Phone is showing low battery. Okay, so here this is dy divided by x square plus 2y square plus z square minus yz minus zx minus xy is equal to dz divided by x square plus y square plus 2z square minus yz minus zx minus 2xy, right? So first you need to, what you can do is, you can see if I subtract this term, lot of the term will get cancelled, right? I subtract this and this, or I will add dx minus dy. Okay, so first what I am going to do is, first I check the question, x square minus yz minus zx minus xy. So what I am going to do is, I am going to find dx minus dy, and then I am going to find dy minus dz, and then I am going to find dz minus dx, right? So if I find dx minus dy, I need to subtract this term and this term, right? So we subtract this term and this term, so 2x square minus x square, so we will have x square, y square minus 2y square, so we have minus y square, plus z square minus z square will get cancelled, so minus 2yz plus yz, because we are subtracting, so minus 2yz plus yz, so we have minus yz minus zx plus zx, so this term will get cancelled, minus xy plus xy, again this term will also get cancelled, because we are subtracting this term and this term. So we have x square minus y square yz, that is 2zx, minus here it is, you change this to plus 2zx minus 2zx. So here we are going to have, sorry, minus yz zx. Yes, you change this to 2zx. So here we are going to have minus 2zx, right? So x will get cancelled. So here we are going to have minus zx plus 2zx. So we are going to have 1zx, right? The question is 2zx here. Now if I subtract dy minus dz, x square will get cancelled. So 2y square minus y square will be y square. Straight away write the answer because I already did this. So y square minus z square minus zx plus xy. If you subtract dz minus dy, you will have z square minus x square minus xy plus yz. Right? This is the one you are going to have. Now we can simplify this. So dx minus dy divided by x square minus y square minus yz plus zx. Now I can write x square minus y square as x plus y into x minus y, and here I can take z common. If I take z common, we will have, I am taking minus z common, or I will take z plus z common, we are going to have x minus y. I am just taking z common. Here I can write this to be dy minus dz, again y plus z, y minus z. Again if I take x common, we are going to have y minus z, and here I can write this as y plus z, y minus z. If I take x common, we are going to have y minus z, and here you can write this as z plus x, z minus x, and if I take y common, we are going to have z minus x. So now I can take x minus y common from here. So dx minus dy divided by, if I take x minus y common, we are going to have x plus y plus z. Now here I can take y minus z common. So if I take y minus z common, here I am going to have plus x. We are going to have x plus y plus z, and here again I can take x plus z common. If I take x plus z common, we are going to have x plus dz minus dx, x plus y plus z. Now the problem becomes very easy. You can group this term and this term. If you group this term and this term, x plus y plus z, x plus y plus z will cancel. So this is nothing but log x minus z, this is nothing but log y minus z. That's it. If you integrate, if you group this term and this term, this term will get cancelled. If you integrate this is nothing but log y minus z, and this is log z minus x common. Sorry, I take z minus x common, z minus x common. So again this is nothing but log z minus x. That's it, right? So when you group, okay, when you group the first two terms, so grouping the first two terms, so dx minus dy divided by x minus y into x plus y plus z is equal to dy minus dz divided by y minus z into x plus y plus z. So this term will get cancelled. Now if I integrate this is nothing but integral d of x minus y divided by x minus y, integral d of y minus z divided by y minus z plus c1. So now we can write later. So this is nothing but log x minus y, this is nothing but log y minus z plus log c1. So therefore our c1 will be x minus y divided by y minus z. So if you group this term and this term, you will get c2 to be equal to y minus z divided by z minus x, right? So group this term and this term, you will get x minus y by y minus z. You group this term and this term, you will get the remaining solution. Now the last problem, I will do this very quickly. So we are going to finish this topic also. So after I am doing this problem, you have to do all the problems in Raisingania book, right? Again it's showing low battery. So I think you will be clear with this problem, right? So first solution is x minus y divided by y minus z, and second solution is when you group this term and this term, you will get C2 to be equal to y minus z divided by z minus x. So I will give you some more exercise problems for you. Now actually I can do one problem, but this problem if you know how to solve a ODE only, I can do this problem. We have one problem in 2006. So that problems, if you know how to solve a ODE only, we can do this problem. I don't know whether I will solve this or I will solve this in ODE playlist. Okay, let me do this. We will finish this quickly. This is 2006. So 2006. X into z minus 2y square into p is equal to z minus qy into z minus y square minus 2x square, right? So first we have to group this, right, because it is not in this is not in a standard form. Pp plus qq is equal to r. First we have to bring that in that form. So I think you can do this, right? So you have to multiply z with inside and q with this side, and you take q common, you will get this equation. So after simplifying, you will get this equation, that is x into, this is already in this format. So when you group this term and this term, you will get q into y z minus y square minus 2x square is equal to z into z minus y square minus 2x square, right? If you multiply here, we will have z into something that is taken to be r. If you multiply q into here, we are going to have minus qy. If I bring this to this side, we are going to have plus qy into z minus y square minus 2x square. Now you want to find two solutions for this, right? So you can, when you group this term and this term, you will get one solution very quickly, right? So first you will write the subsidiary equation. So we have dx divided by x into z minus 2y square and dy divided by y into z minus y square minus 2x square and dz divided by z into z minus y square minus 2x square. So this, when you group this term and this term, so therefore we will get the first solution. Log y is equal to log z plus log c1. So c1 will be y by z. Now we have to find one more solution. Now you find whether you get a multiplier or not, right? Now what I want to do is, so you check whether you get a multiplier or not. If you didn't get the multiplier, what we can do is to find second solution. What I am going to do is, this is a very important problem as well as tricky problem. I am going to do minus 2y minus 2, I am going to multiply this with minus 2y and I am going to add dz, right? So here I am going to multiply with minus 2y y into z minus y square minus 2x square. I am going to add dz, so z into z minus y square minus 2x square, and then I am going to equate this term to first term, which is dx divided by, remember this method is solved in book, they have solved this method. It is not that you have to solve this method also. So x into z minus 2y square, in the book they have solved this method, meaning that you can't find multipliers very easily, that's why they are doing this. So minus 2y I am multiplying here, so minus 2y here minus 2y into this plus dz. I am equating this with first term, right. So now you can see when you add this, when you just make some simplification. So we are going to have minus 2y square z minus, we are going to have y cube, or else we will keep minus 2y outside. Okay, I'll straight away write the answer, right. So you just have to multiply and then you need to cancel the like terms. So if you do that, you will have d of, if you do that, you are going to have this to be equal to d of z minus y square. This is natural, right. So dz is, I can write d of z, this is nothing but dz. I can write minus 2y dy to be minus y square, and differentiate we will have minus 2y dy. So I can write the numerator to be like this, and when you simplify, when you cancel the like terms and cancel this term, you are going to, in the denominator you are going to have z minus 2y square, z minus 2y square, z minus y square minus 2x square. That's it, right. I am just taking z minus y square, I am common. If I take this as common, we are going to have minus 2y is already there, we are going to have y plus z, and then you multiply this, right. So if you simplify this, you will get this, that is z minus 2y square, z minus y square minus 2x square. Now I am going to equate this with dx divided by x into z minus 2y square. So z minus 2y square, z minus 2y square will get cancelled. So what we have left with is d of z minus y square. Yes, so when I cross multiply this, we are going to have, I can write this term to be equal to, it's a very important problem, right. You just have to follow only this method because there is no other method. So I can write this equation to be equal to d of, so I am just making dx here and then taking z minus y square to that side. So we have d of z minus y square divided by dx is equal to, if I bring this term to here, you are going to have z minus y square minus 2x square divided by x. Now you can see I am going to make some, put u is equal to z minus y square. Now you need to know basic knowledge of ODE to solve this, right. So if you put u is equal to 2y square, you are going to have du by dx is equal to z minus y square is u, so u minus 2x square divided by x. So if you bring this u by x minus 2x, right, I am taking x to be, I am dividing by x, that's it. So this I can write this as du by dx minus u by x is equal to minus 2x. This is a linear ODE. So we can do this, we need to solve this ordinary differential equation to get the answer, that's it. So we need to solve this ODE, right. So this is of the form, if you know this, it will be easy for you. Du by dx plus u is equal to some constant or some variable, we will find integrating factor, and then so first I will do this. If you didn't understand, we will clarify this in ODE playlist, right. So you need to solve this equation. I can write this equation to be du by dx minus 1 by x of u is equal to minus 2x. So we need to solve this equation. So for this, first we need to find integrating factor. So integrating factor is e power minus integral p dx. So this is of the form du by dx plus pu is equal to q. This is of the form, like if this is of the form, you will say it is a linear ODE, and there are many ways to solve ODE, and one of the ways is integrating factor. So e power minus integral p dx. So our p is minus 1 by x and our q is minus 2x. So first we need to find integrating factor. So e power minus integral p dx. So e power minus integral 1 by x dx. So e power minus integral 1 by x is log x. So this I can write this as e power log x power minus 1 because I can take minus to log. So this is nothing but x power minus 1 because e power log of something is something. So we are going to have 1 by x as 1 by x is the integrating factor. Now we need to find general solution. So what we are doing is we are solving this ODE to get the solution. This is the only problem is like this. That's why I did this in the last problem. So after finding integrating factor, we need to find general solution. So general solution is u into integrating factor is equal to integral q into integrating factor. This is the formula for general solution, right? Only 3% left. So I'll quickly do this problem and then I'll switch off the phone, right? If the phone is switched off, I think you can continue from here now on. So u into integrating factor is 1 by x and the integral q is the RHS. So q is the RHS, q is minus 2x and integrating factor is 1 by x dx. So this x will get cancelled. So we have u by x is equal to minus integral dx. That means u by x is equal to minus x. U by x is equal to minus 2x plus c2, right? So therefore c2 is equal to u by x plus 2x is the second solution. You replace u to be equal to z minus y square because we have substituted u to be equal to z minus y square. So in the previous problem we have found very easily, but here we are getting an ordinary differential equation. You need to solve the ordinary differential equation to find the answer. So first solution we have found very easily. The second solution is u by x plus 2x, right? So if you have any doubt, we'll discuss tomorrow, right? Actually very easy. You just I'll give the page number. So I think if you rewatch this video, rewatch this sum, you will be very clear with this sum. It's a very easy problem. So we have completed this topic, right? We have completed this topic. Now I'll just tell you the page number of Risingania book. You need to practice. You need to practice almost every problem in the book. If you have any doubt, you can do that, right? Yes, you can find any solution. You can get different solution also. That is not a problem, right? Yes. So actually 1% only I have. So after this, I will let you know the page number, right? So that's it. We have completed this topic. So we are going to start a fresh topic tomorrow, right? We are going to solve a second order linear partial differential equation. That's it. So we have finished formation of ODE using by eliminating arbitrary constant and by eliminating arbitrary functions, and then we have solved how to solve a linear partial differential equation using Lagrange's method of grouping and method of multipliers, right? So we'll see in the next video.